Those are usually after you learn about this. Okay. Yeah, I know. So annoying. All the time. Well, yeah, but it forces you on these computers because I can't turn it.
It's updated.
It's because of the district settings. So when we're working through this stuff, we're talking about inequalities now when we're dealing with two triangles. Now, this is kind of a little bit of a weird thing that can happen. Remember the other day when I was saying put your hands together and open it up? You know, we're talking about angles. Remember when we did that?
Yeah.
Now, when we did that the other day, I said, hey, try and do a 90-degree angle with your hands. Okay. Now, if you're normally proportioned correctly, your hands are probably the same size, right? I would imagine your hands should be the same size. It's a little, my right foot's a little bit shorter than the left, that kind of stuff. So what happens here is that you get two congruent pieces, all right? The legs, if you will, of the triangle are congruent. So when you're worried about this, you're actually making an isosceles triangle, no matter where you move your stuff, okay? What happens here when we start getting with the two triangles, though, is that you get this thing that's called a hinge theorem. And this is a little weird. This little weird thing called the hinge theorem. And it starts with two sides that are congruent. If I have two sides of a triangle that are congruent to two other sides of a triangle that are congruent, I could have different third sides. Because what happens here is that the angle in between them may not be the same. So if this angle and this angle are not congruent, if the two angles are not congruent, the side length across from the larger angle is larger. So let me label this out. So we have triangle A, B, C, and X, Y, Z. And I was going to say we have two different angle measures. It's completely possible to have two legs of a triangle congruent to two legs of another triangle that are congruent, but it doesn't necessarily mean that the triangles themselves would ever be congruent. So what happens here is when you're looking at two separate triangles, which of these two angles is larger between the two triangles, the angle A or angle X? A, okay? So since angle A is larger than angle X, which side length is going to be longer, BC or YZ? Yeah, that's really all it is. Okay. They call this the hinge theorem. This kind of stems from having doorways. Okay, you always have doors in the door jambs. I'm sorry, not door jambs. Where the door here and where the door itself swings. Those two parts are always the same. Depending, we'll say in our school. Okay? But depending on how far open the door is, tells you how far apart you would have to connect them. It's kind of the idea of something swinging. That's why they call it a hinge, because you have like gates. A gate is on a hinge; it swings. Depending upon how far open something. That's what a door hinge. Yeah. How far something opens means how far apart the two ends are. That's where this comes from. Right? And it all comes from or having just two sides that are congruent. Okay? It's a really weird way of writing. Oh, sorry, I didn't realize I put that all the way down. Let me put that up. That might be more helpful. Might be because I'll stare at it. Yeah. The only thing that is different is that I have to find somebody who has the exact same size. Yeah, what do you got?
Since E is AC is the same as the AC, wouldn't angle Y be the same as angle B?
Are the triangles congruent?
No.
So that's your answer. Are all the side lengths congruent? Only two of them are. Okay. Only two of them are. Here, let's just do it. Look at this. You agree that this side length and this side length is the same?
Yeah.
The sharp side is the same. You agree that the side length from here to the pencil is the same as the sharp length here to the pencil? Yeah. We're going to do that. So I get two sides that are the same.
No.
Which angle appears to be larger? Right hand? Left hand.
Right. Left. I think, yeah.
I'm going to go out and say it's the right hand. So, which one of these lengths that we have to connect would be larger?
Wait, I don't know.
Correct. That's really odd. And this is kind of the silly example of how it works. Okay. The example that's in the book talks about. You guys have seen the circus rides where you sit in a swing, and you swing out, and you rotate around. Well, this doesn't change as it goes around, does it?
Like
The length from where I'm out to here to where it's going out there. When the faster something moves, the higher out it goes because it's centrifugal force. Okay? So I am SMRT. So what happens here is that even though the distances don't change, what's actually changing is the angle due to the speed.
So when he's going slow, like this distance to me isn't changing, but if it's going slow, it might be out here, and this is the angle, then as it goes faster, right, and I'm getting ready to throw up, it's maybe out here, it's going to tip the side. I can't just
What was it? What's the right? It's like a cliffhanger where you're against the wall and the floor drops out.
Oh, that's not.
Yeah.
No, I see what
I think they called it cliff when I was your age. They called it the cliffhanger and
you just made yourself sound so old.
is that what it is now? Yeah,
It's
that's
gonna be so much fun.
But that's the idea that and that's why that kind of stuff works, because the centrifugal force, the more force you have of something moving around, that's why it's called, it's you're counteracting the gravity of Earth by pulling you into yeah, and guys, the reason it honestly, this idea of talking about centrifugal force and angular speed, angular velocity, all that kind of stuff, this is all physics. And physics is nothing more than the practical application of math. It really is. It's where math gets its math from, because you can use it in physics. That's where that comes from.
So, just quickly too, so last night I went to go hear this speaker, Temple, I think it's her name, she was voted one of the top 100 most influential people in the world in 2016. Autistic, she got expelled when she was a freshman because there was a algebra she struggled with. And she had an interesting philosophy. She said, you know, why do we have kids? We have to get through
Guys,
this advanced
turn off the phones,
algebra.
please.
Because what she used, she ended up getting a high school degree, college degree, master's degree, doctorate, so she designs all this stuff for a lot of agriculture. But she said all the math and engineering that she does, she needs geometry and she needs trig, and you ready? 6th grade math. So she said it's not the algebra 2 stuff, it's the geometry. She's a very visual thinker. This made sense to her. Trigonometry, and then what she used to figure things out was the 6th grade math, the things that weren't exactly. So it was an interesting concept that this is the stuff that in the real world, what she was using, she has come up with designs and patents for things. This is what she uses. So she actually designs a lot of things for like agriculture, like these like circular, ends that are not used for,
Quinn, you had something. Where the relationship comes into why all this stuff works. Okay. Real quick, couple quick examples. Probably don't even need to really even write all of this out. Between these two, or excuse me, there are two of them here. On the top one, triangle ask, and triangle U, no. Which one is going to have the longer side length for that? Is it going to be the SK or is it going to be YU? The SK. And the reason being because 90 degrees is larger than 70. Okay. On the other one, you have two sets of sides that are congruent, gives you that. The angle in between them is not congruent, which means the side opposite the larger of the angles would be the larger of the side lengths. So in this case, which one is the larger side lengths in the second group? A little bigger angle, yeah, the LN. Okay. All right. Now, this also works going backwards. That when you have two sides congruent, you have going backwards with this stuff. If you have your triangle again, ABC. Ladies and gentlemen, please, enough. When you have the side that is not congruent between the two triangles, the longer of the two side lengths is always across from the larger of the two angles. Again, it boils back down to just doing everything we just did in reverse. In geometry, a lot of times they do that. You work one direction, then all of a sudden it works the other direction because the converse properties of things. Because it becomes what we call a biconditional statement. So here, which one of these angles would be larger, A or X? A. Right. Yes, sir. No, not necessarily. Not necessarily. It plausibly could be, but not necessarily. There's a whole lot of other things that have to happen. Excuse me. So, which means we can talk about ranges of values. And this is where it gets a little weird with the algebra. Just like we did before, we're going to talk about different possible values of x, an upper and a lower value. Okay? Now, if you look at this diagram, we go through the diagram here, which means you probably want to draw a diagram. Why is there like one person drawing a diagram? Come on. When you have a diagram on something you have never done before, you probably want to draw the diagram. So as you're looking at this, In order for any of this to work, we have to have two sets of congruent sides. Right now, I only have one set, RU and TU. Where's my other congruent side? US, yeah. Why? Yeah, the reflexive property shows back up. Okay? Not that we have to do the proofs or anything, but this gives you your setup. Okay? Now that means, as you look at that, you've got the two sets of sides that are congruent. That means that the angles in between them is going to have some sort of relationship. Well, which of those two angles needs to be larger, the 60 or the 5x minus 20? The 60. Okay? So algebraically, that means that the 60 has to be larger than the 5x minus 20. Yes, sir?
This equation would you, so, how do I don't know how to say this in words, but, so 60 equals 15. Would you give the math to where a number equals 10, so like,
Oh, you're thinking like a ratio?
yeah.
No. And that's kind of where you're getting at earlier. It doesn't necessarily always happen like that with angles. When we get to what's called similar triangles, the side lengths will have ratios to them because the angles will all be congruent. Okay? Because you get into it, let me see if I have this. Do you agree that's an isosceles triangle?
No.
Well, okay, it's an isosceles, but more importantly, it is equilateral. Because equilateral is isosceles, so it's a trick question. It was me screwing up. So, equilateral triangle has all sides congruent, right?
Yep.
What are all the angles? 60. Okay. Do you agree that that's an equilateral triangle? Do you agree that all the angles are 60? Oh. That's where you're getting at. Now, what happens here is that the side lengths will be similar because then they will have a ratio, a common ratio. Okay? Whereas the angles will always be congruent. Because you can create triangles with congruent angles, but not necessarily congruent sides. Is that what you're getting at?
Yeah.
That's kind of what I thought you were talking about. So that's a good question. All right. So back to this one, you wind up just solving an inequality again, which we did the other past couple of days, which isn't so bad. Add the 20, then divide by the 5. Then we get, what is that, 16, I believe? So the upper value of it, well, x has to be smaller than 16. What would you think about the lower value? What would the other angle? What's the smallest the other angle could be? What was that? 10. 0. Can the angle be 0?
No.
No. Could that be the lowest value you could possibly get to? That's all it is. He said it. It has to be greater than 0. It has to be greater than 0. What value of x gives you something that's going to be an answer greater than 0? Okay. In this case here, you solve this one then. So 5x is greater than 20, which means x has to be greater than 4. So you have an upper limit and a lower limit. And you're right, you can't have an angle that's less than 0. By not putting, and the reason why this works also is because I'm not putting that little greater than or equal to, it's just greater than. So any value that's larger than 4, bless you, 4.1, 4.000000002, that's still greater than 4, which means it's possible to have something to make it work. Okay? That's where that range, you get that hinge idea of what possible values you get to make it work. All right? So you have a range here, range set of values. X is greater than 4, but it is smaller than 16. where you get that range set of values. You set the one limit to be, it's got to be smaller than the other angle, and the other one has to be greater than 0, otherwise it won't work. Okay, I have one more like that. You guys try this one on your own. I'll blow that up so you can see it. Again, possible range of values. When it says possible range of values, you find an upper limit and a lower limit. Okay? Give that a shot. What does it have to be greater than? Yeah. So hopefully, obviously right now you guys agree that angle N is the larger of the two. Okay. So that means that this 3x plus 18, 3x plus 18 has to be smaller than 90. So x has to be smaller than 24. Okay with that?
Yes.
Yeah. And inequalities, the only thing you have to worry about with inequalities, Josh, if you remember, is that if you're dividing or multiplying by a negative. That's the only thing you have to worry about. And I honestly don't think you'll see that at all in geometry. Alpha 2 you might see it, but other than that, that's the only thing you have to worry about. But you treat everything else just like you would, like you just said, it's just a regular equation. Okay. And then what's the lower limit for it? Do we have to set it greater than 0? Let's be greater than 0. Okay. So subtract the 18. What was that? Negative 18. So x has to be greater than negative 6. Whoa, 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 whoa. Can I have an x value that's negative?
No.
Yes, because pick a number greater than negative 6. Negative 5, right? What's 3 times negative 5? Negative 15. What's negative 15 plus 18? 3. Is that a positive angle?
No.
Yes. It's okay. Remember, guys, it's okay if you wind up with a negative value of x, because it doesn't necessarily mean that you're dealing with a side length or an angle, right? It's one of those things you take a second to substitute back in. So just like we did earlier, we write it as what's called a compound inequality. Oops. We get that. Okay. Not so bad. Let me give you guys a few of these to try out for this evening. Guys, so that's good. All right. Do those, please. Okay.
Yeah, honestly, the first 5 are super fast. The next 4 are, you'll do the inequalities, just like we did those 2 examples of. And then the last 3 are all 6 out of 1 diagrams.
Should not be a problem. Yeah, but don't worry so much about the final part. Because, you know, if it's a proof final thing, I mean, more often than not, we do the multiple choice on it. It's because the time it takes to grade everything and knock everything through. It's one of those things where you'll have a flow proof, and I'll show you what one will look like when we get closer. Pretty easy. No, man, it's after break. It's what's yeah, I agree.